Good afternoon everyone. My name is Pranil Bankar and in today's video we are going to discuss about a data structure algorithm known as Kadanes algorithm. Furthermore, in this algorithm we are going to discuss about why is this algorithm exactly used, what is the problem it solves, and also we are going to understand the logic behind its code. We are going to deeply dive in the code and understand it. Now, moving forward, firstly, let's understand what problem does this algorithm exactly solves. So, this algorithm is used to solve a problem statement known as finding the maximum contiguous subarray of an input array. For example, if we are given an input array of size 10, for let's assume an input array of size 10, so we have to find its maximum contiguous subarray. So to find maximum continuous subarray, let's understand what does subarray exactly mean. So for example, if we take a 10 element subarray as an input, and to be as simple as we can be, let's take this array as 1 2 3 4 5 6 7 8 9 10. Now subarray is basically a small arrays derived from the bigger array. Like for example, let's assume the input array we are taking as a parent array and the small array as its child array. So basically the sub arrays are arrays are which are formed of same elements as the parent array. Like for example, the sub arrays would be of the for example, the input array which we took as 1 2 3 4 5 6 7 8 9 10, the sub arrays of this will be, for example, anything like 1 7 6 5, this is the sub array of that array, or even 5 7 9 10, this is the sub array of that array, and for on. So moving forward, let's discuss what exactly a contiguous sub array means. So till now, the subarray we were discussing about had elements of the parent array in any order. But in contiguous subarray, we have to have the elements of the parent array in the specific order they are in the parent array. So for example, as we took as our input array as the example, which is 1 2 3 4 5 6 7 8 9 10. So the contiguous subarray of this array will be, for example, like 3 4 5 6 7, or 8 9 10, or 1 2 3 4 5 6 7 8, or like anything like that, which preserves the sequence of the elements in the main array. So this is contiguous array. Now what does maximum contiguous subarray of an array means? Maximum contiguous subarray, as it is defined by its name, means maximum means that the elements, summation of the elements in that array, in that array the subarray which we are this contiguous subarray which we are taking shall be the maximum in the given array. Like for example, our input array was 1 2 3 4 5 6 7 9 10. So this would be a bad example to demonstrate this, to make you understand this. For example, let us take an input array of size 5 with inputs like 1 3 minus 5 2 6, something like this, where a minus element comes in between. So in here, to find the maximum contiguous subarray, it becomes a bit complicated as one of the elements is minus, so we can't take the complete array. So and we have to form a contiguous subarray. So in this algorithm, so actually find let's try to understand this by directly by its code. And to understand this by its code, we have an we have a question in lead code which we will solve live on this video and understand by solving and coding what exactly does it do, and understand the logic behind the code. And also we have alternative options to solve this problem, but the Kadanes algorithm is the most optimized and the most used and the most efficient algorithm to solve this problem. So let's move ahead with the coding part. So question we were talking about, where we use Kadanes algorithm to solve this problem, and is the minimalistic time complexity of O of n. So to further understand this problem, if you have not yet understood it completely, let us assume the example of this array given here. So to begin with, as I assume you would have at least understood the meaning of what does a contiguous subarray exactly mean. Now, maximum contiguous subarray what is basically a contiguous subarray. In this array, there are many pairs of contiguous subarray this array can form. So the contiguous subarray which sums up to the maximum sum is the maximum contiguous subarray, and we have to return the sum of that maximum contiguous subarray. For example, if we assume this this array as our input, so here are contiguous subarrays, for example, like -2, 1, which is -1, -3, which is -4, -4 plus 4, 0, -1, -1. So, for example, if this was a contiguous subarray, this is not the maximum contiguous subarray because its sum results to -1, which is for sure not the maximum subarray. Now, let's take another example, like let's start from 2, 2 plus 1, 3, -5, -2, plus 4, 2. Now, the summation of this contiguous subarray results to 2. It is better than the previous subarray, but it is still not the best. Like, so as it is given here, let us take the subarray 4, -1, which is 3, plus 2, 1, plus 3, plus 2, 5, plus 1, 6. Now this sums up to a total of 6, which is the maximum subarray, maximum contiguous subarray of this array, and we have to return the summation of these elements of the maximum subarray, which is 6. Now, to approach this question, first the basic approach, it is basically we have to return a contiguous array with the maximum summation. So here we basically have to apply three conditions, only three conditions. So first, let us prepare by forming an function in C, as there is no function in C to find, no predefined function in C to find the max element of 2. So let's form that function, which is int max, int a, int b, if a is greater than b, written a, else written b. Now this function is basically will be basically used to compare two elements, if to compare two elements and return what is the maximum of them. So in Kadanes algorithm, the basic three principles we have to follow to reach the conclusion of maximum subarray is, first, let's form two variables, which is int sum, which is our dynamic variable, which will be changing with uh each iteration, and it will be our temporary summation of the elements we are contiguous in our contiguous array as we are moving forward with it. So let us assign it with 0. Now let us take another variable int max. Now this variable will define our maximum summation of the contiguous subarray. So first, as we have here it is given, uh, as we are given here, it shall at least contain one element. So let's start with, okay, the given array is nums 0. Let's assume that the first element is our largest in any. Okay, of course here it is not, but let's assume that. Now int max is set to nums 0. Now the first basic condition is a for loop from int I equal to 0 to I less than nums dot size, nums dot length, comma I plus plus. Let's first find the length of this nums. So let's cancel out this, and int length equal to, okay, let's just shorten it to len, equal to size of nums divided by size of nums index 0. So it basically is size of the whole array divided by size of its one element. So this is our length, which basically gives us the size of this array. So I less than n, so it will iterate the whole loop. Now, after this, we have set with this, we are set with this, we are set with this. So this is the first condition, and other than that, moving forward, we have to now let's apply our first condition, which is let's size. Let's add a sum with the variable sum we have used for dynamically increasing or dynamically keeping track or temporary. It is used as a temporary sum variable which is temporarily storing the sum of all the contiguous subarray we are we are dynamically adding to it. So like for example here then sum equal to of sum will be added as some will continuously add the next element of the nums array dynamically, like sums plus, which basically means sums plus equal to nums and nums I. So what this basically does is sum is dynamically increased or is adding the elements of nums array continuously uh, and temporarily. So this is like the basic condition for it. And moving forward, we have to set max as max equal to v using this function here. Okay, let's change the name of the variable to max key. Let's change the name of variable to max key so just to avoid the confusion. So maxi equal to max bracket. The function we have made above will be used here. Max max of max comma sum. So basically we have to find what is the maximum between this maxi comma sum. So maxi will be dynamically updated to the maximum sum to the maximum summation of the dynamically increasing sum. So max equal to maximum. This is the second basic condition, and the first but not the least, the last but not the least, and the most important terminating condition which we here have is if sum goes below zero ever, it will be reset to zero. Sum equal to zero. Now, this is the most basic, most important condition, as whenever the sum goes below zero, it basically means that there was a number greater than the sum in negative. So it basically will always result in in decreasing the maximum value. So here it is necessary that if sum ever goes below zero, it will we shall update the sum value to zero. Now, this is basically our code. I hope you understood what is going on here. So let's just try to run it first and let's show you that if it runs or not. Okay, first let's return maxi, that which is our output. Uh, okay, return max. Okay, so let's run. There was a bit of an issue with the later approach are for finding the length of this nums, as this nums is not an array given to us in an array form. It is given to us is in a pointer form, pointer array of pointer forms. So that size of operator will give us likely the size of an pointer of that array, like 4 byte or 8 byte. So instead we use another function name length equal to nums size. Now this will return the size of this array, and so now this shall work. So let's run this, and okay, so now this works, and I hope you guys understood it. Let's submit it for the final check, and let's see if it gets submitted. Yes, so this is submitted, and 0 millisecond beats 100%. So this is Kadanes algorithm with the time complexity of OFN, the minimalistic time complexity we can achieve in this problem statement. So thank you all for being till the last, and I hope you guys understood this. Thank you.